had an environment, and then we took pieces of a grocery list and placed them around the environment. You can see this person needs eggs and milk. But just by walking through, it really helps you remember the information because it associates a location with each spot. So there were some difficulties with making sure that each place in the environment was really memorable. And in our second experiment, we made sure to make each region of the map more unique. So during the final, we created a story that you would read through. And it was a progression of seasons through this person's eyes. You would get to see what their memories were of their vacation. And with this, we used a game controller, but we decided to scrap that. You'll see why very soon. But this is basically the layout, where we have information that you upload, we slice it up into chunks, and then place it around a virtual world. And then with that concept solidified, we moved forward and created something that we're going to show you today. I'm really stoked about it. So it all started off with Nick and the art. Nick, can you tell us about it?
Hi, I'm Nick. Most of you probably don't know me. I'm an architect, and I am part of the HD class this semester. So I was part of the team last semester when all that stuff was taking hold. But one of the first things that we tried to do at the beginning of this semester was solidify what is this game going to look like, and why is it going to look that way. One of the issues that we had was that the kind of game mechanic component of Recall was so strong, right? Associate items that you want to remember with locations in space, and then use that as a mnemonic to help you understand things. Super easy to digest, but what was lacking was an understanding of why this was happening, how the player is going to be doing all of these things, what is the window that they're going to be looking through to make all of this make sense. So that was the first thing that we developed. I'll talk about that once I run through the rest of these things. So we made a mood board to help out with that we sent out to the artists that had examples and precedents of similar type things. And that was the first step in reunifying all the artists that we had. You can see from the first demo to the second demo, it went through a lot of changes visually as well, and the artists really weren't sure what they were supposed to expect. So with the introduction of the mood board, some of the artists went their separate ways, so we wish them the best of luck and got some new ones. But the group that we have now is looking in the same direction, and that's really exciting for us visually as well. Asset batch production as well, that's something that I've been working with a lot. So basically, we're moving forward now this semester to procedurally generated environments, which they'll talk about later, which calls for a high quantity of unique assets. So we had a couple options. The first thing you might do is decide to design by hand, so many of these different assets. But that just wasn't going to work with our resources. So instead what we're doing this semester is we're doing batch production. So instead of designing each one individually, we make a definition, and then from the definition we'll produce X amount of completely different, unique assets within the same family. So you'll see, we've got a coat hanger, but it's not just one. We've got like 100. We've got 100 different ottomans, and it was really quick and easy to produce that. We got the poster and logo figured out, so now would be a good time to talk about the story. So Recall Story now. You play as an AI who is slowly coming to terms with itself, its place in the world, why it, what it does, who it is, those sorts of things, and you help. You understand these things by acquiring knowledge through your memories. And this way we can incorporate what the player is doing before they enter Recall, which is identifying a document that they want to memorize and bringing that in. As far as the game is concerned, the player uploads that document to the server and gets, in return from the server, what we're calling a chip or a memory box or something, a physical item that they can get in Recall and insert that into a terminal, which will contain all the information for that procedurally generated environment, for which you, the AI, to go inside and explore. Once you've properly recalled all the information within that chip, that chip gets added to your collection, kind of your bank of knowledge. And once you've acquired a certain amount of chips, right, you get to assemble personifications of different concepts that you now understand thanks to your knowledge of all of these documents that you've acquired. So that's looking really interesting. That's the really promising story that we're using moving forward, and that's where we get the logo from. And the logo now is the basically the profile of how the chip is going to insert into the terminal. So it's more or less like a USB shape, and so that's where that comes from as well.
So I'm Clint. So the first introduction to the story that was mentioned is the fact that it's actually from the launch scene. So when you start the game, you're at a black screen, and you have some information that says turn around. You turn around and you see a white circle that you're supposed to go to. Once you look at it, you'll see this center green spot. Once you look at it, you're automatically transferred to that point, to the gaze mechanic. At that point, a terminal comes up, and then you're given the description of things that you can do. This terminal over here. Once you press play to start the game, then we have some cool animation. It rotates open, and the memory palace it is available to you, and you can walk into it. So that's your first description of the game. So at this terminal, you can see that we have a few options available. This is start menu, where you can choose your type of song and what title you want. We also have training, which is exactly the same as start, but it just gives you more options. It tells you like how to do things. There's arrows pointing and more descriptive for the people that actually need it. We have options that can control things like the gaze speed, movement speed, even font size. We actually have a Recall Wiki, so that allows you to go online and find other people's information and download it into your own game. And we also have a history, which shows you your past and your past progression, and a user menu that allows you to switch between users and change to see their own history and their own personal documents. Now, the most important feature that we implemented was gaze. And originally, you could see that we tried with the joystick, and that had several problems associated with it. So with the joystick, even though it was useful, it has like a right control where you rotate your body. And even though your body is rotating in the game, it doesn't in real life. And so your brain recognizes this disconnect, and it causes motion sickness. We also noticed that pressing up and down, while it doesn't have that same motion sickness, we realized that if you give people this freedom to move anywhere they wanted to, then they would move anywhere they wanted to. So they would jump over cliffs, and they'd wind up in the ocean, and if there was a place to get stuck, then they would get stuck. Somehow they would get stuck. So we decided if we use gaze, that allows them to only move the direction that we wanted to. And that's very helpful because the point of Recall is not to go explore the virtual reality, even though that's a benefit, is to memorize words. And if we can make them do it quickly and efficiently, then that's the best. So that's why we implemented gaze. The final problem is that to connect the Bluetooth joystick to the controller, it required a lot of things. For instance, you have to pair things, and you might have to unpair if it wasn't working correctly. If you have multiple devices, then you can pair it to the wrong one. If it didn't work out, then you have to like go through the it was just too much. So that's why we use that. So one of the advantages of using a gaze is it's very simple. So the three things that we're considering using before are the Google Cardboard, which is basically it looks like this. It's very cheap, and it only has, well, it's inexpensive, and it has one button. The other ones were the Samsung Gear and the Oculus. Now the Samsung Gear has a trackpad on the right-hand side, and the Oculus, you actually use the keyboard. But if you were to use either of those, then you wouldn't be able to use things that don't use that input. Therefore, if we use this one, then it'll work for all of them. So one of the disadvantages of using this case is its simplicity again. And so, for instance, at the end of the game, when we have to try to get the users to select the words that they memorize to see if they can memorize it, it's kind of hard when you only have one button on the side. So if you had a joystick, you could scroll through things, you could use back, and you could have a pause menu. Now we don't have any of those features. So that's something unfortunate.
So in terms of the technical updates, as Nick was saying, we switched our game to be procedurally generated environments. So basically, I'm going to step through and show the different things that we have generating right now in our scene.
The idea behind procedural generation was that every time you upload the document, you're going to be entering into a world that is specifically catered to that document, so that you're not kind of we're not using the same place and then exchanging the information and getting confused and all those sorts of things.
So for example, the first thing we generate is a floor plan. So it's just the floors that you're actually going to be walking through. And the number of rooms and floor size is dependent on the actual document. So the number of words that are going to be per room. And those numbers are basically very scalable. So I could generate 52 rooms and it would make some crazy maze. The second thing that we wanted to do was variable heights. So as you can see, sometimes the rooms are very tall and sometimes they're short. We want to hook this up with text file semantics, which isn't working right now. Right now it's purely random. But we want as many variables as possible to make it feel correct based on your text file. And we also have, sometimes the ceilings aren't there so you can see the skybox. So that's the ceiling and height. And then finally the actual inside the game, we generate these objects. So the objects that we're generating are the actual text and the procedurally generated objects that Nick was talking about. So for example, that ottoman will be placed, right now it's placed randomly, but we will start adding more meaningful information to the actual placement of these things. And the final thing that I'll show during the demo is our gaze point generation. So because the level, we don't know ahead of time what it's going to be, the actual gaze points need to be put into smart spots so that you can traverse the level. So what we're doing is basically, it's a simplified A-star that whenever too much of a turn or anything is out of line of sight, we generate a new gaze point. So now I'm going to play through it, and Lucas is going to talk about what's going on.
So the really important aspect that we learned in the first semester about how to make this actually work is to make each separate space feel viscerally different. So color variation and texture variation isn't enough alone to do that. That's why we implemented ceiling heights variation. That's why we took away the ceiling sometimes, because that really does change the feeling that you get when you walk through a room. The transition from one room to another is really the important thing to focus on. So as you can see, Viraj just looked at a gaze point right next to the gaze of space. And he's walking towards the next one. And so you can see right here already a very different feeling of being able to see the outside world. It helps chunk the rooms naturally so that you can know. VR is pretty immersive, but so it helps chunk the rooms more naturally so you can make chunks in your own mind of the information. Nick, would you like to tell us about how we're going to improve these environments?
Yeah, so the great thing about this right now is that each environment, each kind of little compartment, each block in each of these rooms has a unique color right now, a unique ceiling height, a unique shape, a position in space. It's populated with different geometry. That's all well and good, right? But that's like first base. That's the first kind of minimum that we can do. But there's a lot more that we can do as well, right? So right now, the transitions between these things are just passing through a rectangular opening that's connecting these together. You can imagine how it would be more memorable to walk through an arch than it would be, let's say, to walk through some rasta beads. And next time you can walk through some ribbons, those sorts of things. Something else that we want to do is implement texturing and patterning as a way to differentiate all of these spaces as well. So right now we're using simple colors like this, but we want to incorporate the textures into the procedural generation as well, so that with a small number of patterns that we generate ahead of time, we can produce a wide variety of different looks and those sorts of things based on the colors that we have in there.
And the thing that we really focused on here is making everything that we're doing scalable for change down the road. Like if you press play again, Viraj, there's going to be a brand new procedurally generated environment that we've never seen before. And it's going to, we can also play with now that we've defined our modular blocks of how we're building the environment, like Minecraft uses the cube as their modular block. We're using rooms as our modular block. We can start, now that we've made a first pass at the modular block, we can start doing new modular blocks that are more interesting than just Tetris pieces.
One more thing, the way we actually create these pieces is using a directional type system. So the nice thing is, to represent any of these pieces is a height number and a string, which is basically a linear path to go through the level. So northwest, west, north, a square would be like west, northeast. And so we can represent, we can save these files very small, which is good for the fun.
Yep. So now that you've checked out our environments, we're going to talk about some text processing.
So moving on with the technical aspect of recall, this gets like super technical, but text processing is like the hidden magic of recall. So the process from the moment you upload the document to what you see in VR is done here, and this is text processing, or the outputs for text processing become the inputs for procedural environment generation. Meaning that all the variables that you need to scale the heights, to get the path length, node points, how much text needs to be placed at the pedestals, and what kind of objects need to be drawn upon. All this happens in this black box. So the biggest challenge we faced is that no one has ever been there or done this, and so we jumped into it, and we are doing it. The biggest achievement was that last semester we were able to make a complete design pipeline for recall, and we were able to achieve the major chunk of it. So last semester we were also able to demo to pull out a keyword with an associated object, and this was actually done only for a single sentence, but we achieved it, and that was a big thing for us. So this semester what we did is paragraph looping. So Recall uses Python for text processing, and the functionality of Python is that it does a looping for only a line. So we had to come up with a code that loops through a paragraph. Now this is just an example that we picked up a news article from the internet, but we'll show you how we make it readable for Unity to show it here. So we use Python to loop through the whole thing. We used open source package in order to achieve this functionality. And then we did keyword extraction and customization. So if you see this, that for each paragraph, we are able to pull out more than one keyword. And we're not just able to do that. We can give you a single keyword, key phrases, key sentences. So the user gets an option now. If he doesn't like what Recall is giving him as the keyword, he gets to choose. And that's how we have all these keywords, and then he can just choose later on down the line. Now, from here, we made an XML parsing thing. So this is where you get to see this is the keyword and this is the paragraph associated with it. And in future, once we get the tagging more accurate, we are going to be even inserting like a key object that gets associated with the keyword. We were able to demonstrate this last semester for a single sentence, but in order to achieve it more in depth, like meaning if you see that this particular color scheme has to go on the walls, or like this audio has to sync in with that particular topic to kind of bind emotion and what we are exploring, all that would need like little deep learning concepts and natural language processing, and that is something which we are still working on. Next steps is that we are working on how to take different file types like PDF, Excel, HTML files, and then convert to .txt and make it into this format so that our engineers can use it for a website. Apart from that, we are also working on how do you differentiate between prose and poems and songs, and how do you parse those all and like throw it into these procedurally generated environments? Yeah, that's pretty much from text processing side.
The nice thing about this is right now, currently our pipeline for basically .txt files goes all the way through. So the demo that we were showing you was a text file with a list of cards, and the asset gets pulled, and it makes the XML, and we read it. So that pipeline is working for text files. So we want to move on to PDF Word, etc.
Yeah, and we were able to crack the way to do for PDFs, and slowly we'll start nailing down one by one, and then look at different formats, like, you know, how do you do for a chapter versus just a single document, or like song versus poems, how do you know what is blank verse and stuff like that, more complicated stuff.
Wow. PhD student.
Master's doing PhD, yeah.
So this semester was a real boon for us because a lot of people joined our team, and it really transformed our capabilities. So that is actually leading us, you know, since we also solidified our art direction as well as our engineering backbone, that helped everything fall into place, especially over the past 3 to 4 weeks. And we're going to showcase the game at a couple of places. We already went to E2 and SIMD. We'll also be going to GDC along Magnus and NAB later on. But since we have now that we have our scaffolding, so to speak, from the aesthetic side all the way to how it's going to look in zeros and ones, now it's time to build the end and include things like spatial audio to help direct the player and where they need to go next. Another interesting thing that happened during just exploring the environments that we've made so far, it's kind of difficult to know where true north is. So an idea of implementing spatial audio is to have one type of audio source always come from a certain direction, very far away, and that'll just help the person orient if they're facing north or east. And refining the procedural environment generator now that the scaffolding is there to be more artistically beautiful is that's our main focus, as well as gamifying each little gamifying your interaction with the game. So rather than just passively tapping or gazing and then going to each spot, we want you to interact with the information, and coming up with little mini games that will change is that's also our goal for the second half of the semester. One thing for navigation, we do have it working with gaze, but it feels a little unnatural the way it goes right now. But we have a really cool idea for allowing you to teleport from one place to another, so you can move a little bit more freely. And the aesthetic, that's already been talked about. The aesthetic development and the file compatibility is what we're looking for at the second half of the semester. So that's pretty much it. Any questions? Anders?
Well, first of all, I want to compliment you on your amazing iteration on it. It's really changed a lot and become a lot better because of it. I was wondering, with the text files, if you're reading about children in a caretaking book, you will want a picture of a child that is happy or playing or whatever. However, if you're reading about child processes in a programming book, that is a significantly different kind of child. How are you distinguishing the context of a word? How do you plan on doing that for words that are meaning the same, that have the same wording, but mean something completely different in different contexts?
Yeah, that is a very, that is the core and that is like the vision, but it would mean like sentiment analysis and text mining kind of stuff. and those are some things that we basically still need to get an understanding of. Right now, the text processing team is very small, and we just started exploring these stuff, so we kind of have an idea on how to approach it, but we need to do a lot of digging in order to, solve that problem. But however, we need to like make kind of dictionaries or databases and like do tagging of everything and like branch out everything and like make bins. Like this is that sector, this is another field, and that's how it has to smartly choose which way to go. Like it gets complicated, and I don't want to like speak too technical right now, but I can talk to you about that later.
If I were to put in my 2 cents about that, it's actually not that bad to get it wrong. In fact, the method of loci, it hinges upon weird things happening. So we made the ceilings really small, so when you zoom in, you're like, whoa, shit, limbo. And, but I mean, let's say you're talking about the bank of a river, and we are assuming that you talked about the Bank of America, and we put a money bank in like an accidental association. It's weird, and that's actually not bad. So
random association also actually works.
And I think the other thing to remember too is that the way that we're going to be moving forward, at least for right now too, is we're not going to try to kind of create an environment for every concept that can possibly be created, because then we're basically trying to like create the internet but 3D in VR, which is just completely beyond the scope of anything. So instead, our approach is let's create environments that are going to be unique, identifiable, memorable, right? So you can remember being in that space and can remember that concept, because it, like nouns like a bank or a child, right? Those are easy. But if someone's trying to remember something like an abstract concept, right? There's no real way to solidify that in some geometric space. So instead of picking that fight, we're going to say, okay, no matter what it is that you give us, we're going to try our best to guarantee that your environment, that information is going to be presented in a unique and a memorable way that you'll be able to recall afterwards, regardless of whatever it is that that was.
and that's one of the strengths of the AI lore. Because the AI lore is you are a digital being. How do you see digital programs? How do you see, what's your perception of other digital entities? And so we're making the argument that it's going to be spatial. And your understanding of documents is in a virtual space. And since naturally different programs have different outputs, so this clashing of digital styles, this clashing of digital flavors, we're going to stick on the simple side, but this clashing actually benefits us, and that's what we're embracing with our current direction.
So you guys are saying that your level generation was procedural. Is it purely random, or do you have some safeguards to prevent, like, there is like some astronomical chance that two rooms could randomly be the exact same one after another? Do you have any safeguards for that? Do you think that's...
Yeah, it's not random. It's basically pulling from a list, and you don't choose that one again. But yeah, so it's possible to get it again eventually, but yeah.
You mentioned that the numbers that define the room in terms of ceiling height, room order, etc., it can be saved to a very small file. Have you successfully implemented a save load mechanic?
No, we've only brainstormed it, and we know how to basically import export. It's just a matter of actually print.
So that will, but clearly save load is going to be mission critical, particularly if you want to revisit and study.
Exactly. Yeah, it's very important. Yeah.
Okay, awesome.
And it was all in artificial intelligence.
Right. So how can we support you?
For money.
Sorry.
I said, show me the money, but it.
It's probably copyrighted.
Do you have any announcements of activity that we can broadcast on your behalf?
We're going to NAB.
Engines.
Like it's on Facebook.
Like us on Facebook.
Awesome.
We'll let you know. We'll definitely let you know when.
Please send those links so that we can propagate those out.
We'll probably start making a bigger plus now that what we're creating is taking shape.
Definitely take the shape.
And yeah, if you know artists, engineers who are well versed in NLP or deep learning concept, please send us our way.
Out go.